The properties of an ellipse that come to mind probably immediately are the center, the vertices, and the co-vertices. That's weird. The center, the vertices, and the co-vertices. And they're what we use most directly to graph an ellipse. However, there are other properties that we sometimes want and need because an ellipse can be defined by two foci and the length of the major axis. So here is going to be our first focus. There's going to be our second focus. And the major axis is the longer axis. It is the set of points whose distances from the foci add up to the length of the major axis. So if I call this distance 1 and that distance 2, these two distances have to add up to this whole distance. So no matter what point on the ellipse I pick, the distance to focus 1 and to focus 2 will add up to, in this case, because this is going from -5 to +5, they will add up to 10. So from here to there is a length of 10. So that's one of the ways of talking about an ellipse, and sometimes we care about those. So let's look at the properties of what the pieces of an ellipse are. First, they're split into horizontal and vertical ellipses based on which axis is larger. I think that it's more interesting to talk about the horizontal axis and the vertical axes, but for naming reasons, we talk about the major axis and the minor axis. So the major axis is the longer one, the minor axis is the shorter one. And it's all the way from here to here is the minor axis. The major axis is from one vertex to the other. So I color-coded these. The center is h comma k. The vertices are h plus a, h minus a, comma k. So here's h comma k. And then if I add a to the x coordinate, I get over here. If I subtract a from the x coordinate, I get over there. So a is this distance from here to there. In other words, the major axis is 2a. The foci are here and here, so we start at h comma k and then add c or subtract c from the x coordinates. The co-vertices instead are up and down, and that's up b or down b. So you should know which letter corresponds to which thing, and you need to know that vertices and foci are along the major axis, and the co-vertices are along the minor axis. In ellipses, the relationship between this distance in blue to this distance in green and this distance in red is that c squared, the distance to the focus, equals a squared, the distance to the vertex, minus b squared, the distance to the covertex. Now all of these distances are measured from the center of the ellipse. Same thing holds true for vertical ellipses, except things got changed in terms of where they're being added. So the vertex still corresponds with A, foci still with C, covertices with B, and this equation is still true. However, the major axis is now vertical, so it's added to the y-coordinate. The foci are now on the major axis still, so it's added to the y-coordinate. The covertices are now horizontal, so it's added to the x-coordinate. The properties that I might ask you to find are the center. The center is the midpoint of the minor axis, of the major axis, and of the segment connecting the foci. So no matter what I give you, you should be able to figure out where the center is by taking the midpoint of them. The length of the major and minor axes are given by 2a and 2b, and for the major axis, it's the distance between the vertices. In the minor axis, is the distance between the covertices. And lastly, vertices, covertices, and foci. We said this was A, this is B, this is C, is the distance from the vertex from the center to each of these things. Once we know two of those distances, we can find the third using c squared equals a squared minus b squared. So let's do some practice. Identify the center, vertices, covertices, and foci of the equation. So the center is going to be 0, comma, negative 6. Based on this 25 being bigger than that 16, we know that it's the y-axis is bigger, so that means that it's a vertical ellipse, which means that the vertices are in the y direction. Also, this tells me that a is square root of 25, which is 5. This tells me that b is square root of 16, which is 4. Because it's vertical, I know that for the vertices, I'm changing this. So it's 0 minus, or 0 comma, negative 6 minus 5, and 0 comma, negative 6 plus 5. So I use these 5s to change the y-coordinate because it's vertical. For the co-vertices, instead of changing the y-coordinate, I'm going to change the x-coordinate. So they're both going to become a negative 6, and I'm going to change them by 4. So it's going to be up 4, or right 4, and left 4 are the co-vertices. And the foci, using c squared equals a squared minus b squared, I can say 25 minus 16 is 9, so c equals 3, and the foci are along the same direction as the vertices, so also vertically. I'm going to take 0, comma, change this by 3. Now change it by 3 in the opposite direction, and those are the pieces. Center is 3, comma, negative 6. That gives us A is 8 and B is 6. Because A is bigger, I know that this is a horizontal ellipse. I can say that the vertices, because they're horizontal, we're adding or subtracting 8 from the x-coordinate. So here's subtracting 8. Here's adding 8. For the co-vertices, I'm adding or subtracting 6 from the non-horizontal, so the vertical coordinate. For the foci, I'm taking, well, I have to find what c squared is a squared minus b squared. So this is 64 minus 36 is 28. So c equals 4 squared 7. So along the direction of that's horizontal, I am changing by plus or minus 4 square roots of, I'm sorry, I did that wrong. 2 square roots of 7. An ellipse has vertices 2, 6 and 2, 10, and the length of the minor axis is 1. Where are the foci? So here's the vertices. The center is going to be halfway between them. That's what we said here. Center is halfway between those. So the center is 2, 8. Based on the distance between 6 and 8, I know that A is going to be 2. We were told the length of the minor axis is 1, which is double B. So B is a half. And we know that c squared should be a squared minus b squared. So 4 minus a fourth is 16 15/4. So c equals square root of 15 over 2. Now, that means that the foci are in the vertical direction, where because of 2, 6 and 2, 10, we know that it's going to be in the vertical direction from the center by this amount. So the foci are at 2, 8 plus or minus square root of 15 over 2. The foci of an ellipse are located at these 2 points, and the major axis is 24 units long, so A is 12. Based on these, that tells me that the center is halfway between them, so that's 13, 3. That also tells me that if I go from 13 to 20 or from 13 to 6, that the distance there is 7. So c squared equals a squared minus b squared. Add b squared to both sides and subtract 49. We get 95. So b equals square root of 95. So now we should have enough information to write the equation of the ellipse, because we have this was the center. So we know that it was x minus 13 squared. A was 12, so a squared will be 144. And I'm putting that under x because the foci were changing in the x coordinate. Y minus 3 from the y coordinate of the center. We already used a is 12, b is square root of 95, so b squared is 95 equals 1. One last piece. Eccentricity rarely comes up, but it's defined as c over a. Informally, it represents how thin the ellipse is. So here's a wide ellipse and it has 0.9. That means c is very close to a's value. Here, it's a little wide, and here it's almost a circle. If we had the eccentricity being 0, that would mean both the foci were in the same place.